Okay, so this is finally section 6.2. Do you remember how we started backwards at 6.3 and then we skipped ahead to 6.1? Now we're finally at 6.2. This is great. Okay. So exponential growth, the more you have, the more you get. It grows faster and faster and faster and faster. Okay. Exponential decay, the less you have, the less you get. Okay. It decreases really fast at first and then it kind of slows, but still decreases. Okay. Can we maybe remember what those graphs look like? Exponential growth, exponential decay. Quantities that grow or decay by a factor or a percentage at regular intervals are exponential. Okay, so this is an important phrase right here. The rate of change of the quantity is directly proportional to the quantity itself. Mathematically, that means this right here. Okay, the rate of change, ooh, that slope, derivative, is directly proportional to the amount itself. Okay, directly proportional means there's some sort of number, scalar, okay, multiplied to the quantity itself. Okay, that's y. So dy dt equals ky. So instead of dy dx, I said dy dt. Why do you think I changed it to a t? Because we're talking about time. Okay, so the rate of change is directly proportional to the quantity itself. Derivative equals a number times y. That's what that means. Okay, let's go ahead and use our separation of variables skills. This is why I teach that first, to solve this differential equation one time. Let's separate our variables. What do we do? We're gonna have to take that y over, right? So 1 over y dy equals, I'm gonna leave k over with the dt. You okay, Kareem? Okay. Are you okay? We took the y and we divided it over to be with the dy. The y needs to be with the dy. And then I took the dt and multiplied it over with the k. Again. So now let's integrate. When we take the antiderivative of 1 over y, we get thank you for the whisper. Okay. What about the antiderivative of k with respect to t? Kt plus c. We don't even have a kt in class today. Kt. A kt. What's the problem? K is just a constant. Okay, so now how do we solve for y? We have to do that e thing. E. E to the natural log. Cancel out and we have y equals e to the kt times e to the c, which is really just a c, right? Oh, this is great. If I have former students have called it kect, but sect is fine. Whatever. If dy dt equals ky, then every time we solve the differential equation, we get y equals c e to the kt. Do you see why we're talking about exponential growth and decay? What? Where's the e?
You made it sense. You just wrong. You made it.
I don't care how you remember it, but remember it. Okay, what does this remind you of? Yep. Something back from algebra 2. There was maybe a P, maybe an R. PERT, right? Let's talk about this equation right here. If t is 0, what's e to the 0?
1.
1. So this c right here. No, but what does it stand for?
Constant.
It is a constant. It's the number when. Yes, it's the initial amount. If t is 0, e to the 0 is 1, and we're left with c. So whatever our initial amount is when time is 0, that's c. Okay, so the good news is when we have the phrase, the rate of change of the quantity is directly proportional to the quantity itself, blah, 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 blah. All right, y equals c e to the kt, and we don't have to do the calculus. We've done the calculus one time. That's all we need to do. Okay, so really today it's all about algebra. What a nice break. Here we go. Let's start off simple. The rate of change of y is directly proportional to y. Let's stop. That means dy dt equals ky, which means y equals c e to the kt. Boom, we know it. No more calculus. Okay. Well, then it's not exponential growth and decay. Okay, we know that when t equals 0, y is 2. And we know that when t is 2, y is 4. What is the value when t equals 3? So first, we need to take this information and we need to actually figure out what is c, what is k. All right. So let's use one as a time. Ooh, do we know c? You bet we do. When t equals 0, our value is 2. Okay. For those of you who aren't quite convinced, if we have the coordinate 0, 2, when we plug it in, e to 0 is 1, so c is 2. Okay. So now we at least know that y equals 2 e to the kt. So now let's use the coordinate 2, 4, and let's figure out what the heck k is. Okay. So we have 4 equals 2 e to the 2 times, whoops, k times 2. Do you agree? 2k would be fine. All right. How do we solve for 2? Divide over the 2. And then, what'd you say? The circle thing. The natural log of 2 equals 2k. Hey, guess what? You're gonna need your calculators. Get them out.
Actual thing is. What happened with actual numbers?
It's been a long time since that's happened, my friend. Long time. All right, what do you get? 0.347. Let's go out a couple more decimal places. So let's double the decimal. So give me 6. 3, 4, 6, 5. Why would I ask you to do a few more decimal places here? This isn't our final answer, is it? No, we're gonna have to use it in our equation. Okay, so we know that now y equals c e to the k t. Here is our model. Okay. Do we have exponential growth or decay? Growth. Our exponent's positive. If our exponent was negative, we have exponential decay. All right. So now if I want to know what's the value at t equals 3, then we're going to take this equation and we're going to plug in t equals 3. And we get so 6.657. We did it. That was the first problem. Okay. All right. Questions before we go to the second problem? All right. Go ahead and read through the second problem. Is it plutonium? I think it is. AP Chem people, is plutonium PU?
Yeah.
Plutonium, woo, nice job. Okay, so we're talking about half-life, right? So y equals c e to the kt, but this time k is going to be what kind of number? Negative, because we're decaying, right? Half-life. Okay. 10 grams was released. What does that give us? Yes, our initial amount is 10. So we know that y equals 10 e to the kt. In the end, we want to know how long it will take to decay to 1 gram, okay? So that's what we need to figure out after we have our model, but first we need K. Our half-life is 24,360 years. Let's talk about half-life. We know that it will take 24,360 years for this 10 grams to decay into 5 grams. Watch this. We divide over 10. What do we get? Do you think that it is a coincidence that we got 1/2? No, we're talking about half-life. So here's the cool part. You don't actually have to know what the initial amount is, because you know that when you take the amount and you divide over the initial amount, for half-life, it will be 1/2. Okay. All right, so let's figure this out. Let's do our little swoopty swoop. The log base E of 1/2 equals 24,360K. All right, what do we get? Negative. Oh my goodness. What? Oh, you're very verbal today about how much you are enjoying this. Now, let's take this equation. I want to know how long will it take to decay to 1 gram? Where am I plugging in 1? So 1 equals 10 e to the negative 0.000028 t. And now we have to solve for t. Right? If I move this over 5. Okay. Now, when I take this 10 and I divide it over, we get 1/10, 0.1, whatever you want to say. Now, I could have worded this problem. How long would it take for your original amount of unknown? Like I could have not given you 10, and I could have said the half-life is this. Tell me how long it'll take for only 10% to be left. So then you know y divided by c is 0.1. Okay. Just giving you some ideas for things you might see later. Okay. Now let's go ahead and solve for t. Now, realistically, this number should be bigger or smaller than 24,360. Significantly, right? Okay. So we have the natural log of 1/10 equals this gross. Your calculator tell you how many years? You're just letting everybody else do the work for you? Okay. What? 82,000. What? Are you using the actual value, Isaac? Yes.
How accurate do you need this to be?
Accurate enough. This one, it's harder to be accurate because the numbers are so big. Okay. Example 3, we're going to have an easier time being accurate. I am so excited for example 3. It's it's a crop. What? I think it's a grain. It's a vine plant. Okay, they're vines. Okay. Native to where? East Asia. Okay. Now, so the rate at which acreage is being consumed by a plot of kudzu is proportional to the numbers of acres already consumed at time t. So it's like this vine that goes in and like disrupts the crop. Okay. All right. I don't think quite as fast as Jumanji. All right. So since we know all that, we know y equals c e to the k t. Awesome. We know that at t equals 1, 2 acres are already consumed. And at t equals 5, 3 acres are consumed. How many acres will be consumed when time is 8? I don't even care if it's hours, minutes, days, years. Okay. It doesn't matter to our problem. Can we fill anything out with C or K? No, but we need both C and K in order to be able to figure out how many acres will be consumed when T is 8. So let's do this. We know that 2 acres are consumed when T is 1. And we know 3 acres are consumed when T is 5. Is this what? Is it a system of equations where we have 2 equations and 2 unknowns? I know you're excited, just like I am. Okay. What are we gonna have to do? Oh, what? What'd you say? Substitution. But you know what? Look at how easy this is gonna be. I'm gonna take this one because my exponent is smaller than this one. Okay. I can solve for C. So I can say, all right, C equals 2 divided by e to the 1k, right? And this C legitimately is the same as this C. Okay. I know we've been kind of big. So now 3 equals C. Well, our new C is 2 over e to the k times e to the 5k. What does this equal? We really missed you last week. I made that comment, didn't I? Is it 2e to the 4k? Yes. When we divide and our bases are the same, we subtract our exponents. Oh, this is excellent. Yep. Who said Miss Holman? They kind of, sounds it. Okay, so now we can divide over the 2. Cole. Yeah. Thank you. That is what I wanted to ask you. Okay, we can do it. How do we rewrite this? Okay.
What's that?
What's K? No. 101,366. Okay. What? No, we can't plug the 8 in yet. Because what do we need? Now we need C. So now I'm going to come up here. 2 over e to the k. What is our C? Eight 07205. Okay, so now I want to know how many acres will be consumed when t equals 8. So when t equals 8, plug 8 in for t, 1.807205 in for c, and 0.101366 in for k. Let me know what you get. You were wrong.
This is a layered joke, actually.
By the end of the week, Cole is going to be ungrumpy and Matt is going to stop making C jokes. That's our goal. Matt, what's our answer? Is it really? Dang it.
This one was layered. I
I don't want to be laughing.
This joke will last a long time. It'll get funnier every day.
Okay. Are we okay with the math that we just did? Okay. My biggest suggestion for you is if you get to a problem that has no initial amount, if it's half-life, you don't need an initial amount because you know y divided by c is going to be 1/2. Okay.